Alright, this is going to be part 1 of my 3-part video series on chemistry review. The first topic we're going to be focusing on is stoichiometry. So we can just go ahead and get started here. Now the first thing, there's a couple things to know about stoichiometry before we start. So before you start doing the stoichiometry and finding out how many moles are in a molecule, you have to know how to balance equations. So we did that in the last semester, so I'm just going to give you a sample problem here. So we have HCl plus NaOH yields H2O plus NaCl. Now in stoichiometry we have, this is our equation, and a good thing to know is you're always going to yield a salt and then water. So we have our Na and then our Cl that's going to come together, and then our H2O. Now the HCl is going to be your acid, and then your NaOH is going to be your base. Now before we start getting on to the problem, we have to know the difference between molarity and molality. So the equation for molarity is going to be moles over liters. So that's molarity. And then the equation for molality is a little bit different. It's going to be moles over 1 kilogram of solvent. And then the molarity one is going to be moles over 1 liter of solution. Alright, so that is going to be, get a towel here. So those are 2 really good formulas to know. And then in our sample problem, we can, just a moment. So in our sample problem, we're gonna have 40 grams of NaOH, and then we're going to have 40 grams of NaOH, and then we're gonna find out how many moles of salt are in that. And the salt is the NaCl. So the first step we have to do is find out the mass of NaOH to see how many grams equals 1 mole. So we have NaOH, and you're going to need to get out your periodic table for this one. So I kind of have these already written down. But if you look, nitrogen, or that's not nitrogen, Na is going to be 23, and then oxygen is going to be 16, and then hydrogen is going to be 1. So these all equal to 40 grams equals 1 mole. So that's our 40 grams of NaOH there. So we're going to use that. So now we're going to set up our equation. So here we have 1 mole of NaCl, and then we're going to put that over of 1 mole NaOH, and then if we want to cancel out the NaOH, we're going to put 1 mole over 40 grams, and that was our 40 grams right here. So that's 40 grams of, sorry, my handwriting's not the best, NaOH. So to cancel these out, we have to put them opposite to each other here. So we can cancel those out. And then we have to times it again by 1 mole NaCl over 1 mole NaOH. And just a quick note, before you start with any of the math, you have to make sure this equation is balanced. Lucky for us, this equation is already all balanced, but it does make a really big difference in your equation if it's not balanced, so you have to make sure if it's like a 2-to-1 ratio or a 1-to-2, that's really important, but since this one's a 1-to-1, we don't really have to worry about that. So moving on, we have the 1 mole of NaCl over 1 mole NaOH, and then we are going to multiply all of the tops and then divide by all of the bottoms. So I already have that math kind of figured out. So then that's going to equal 1 mole of NaCl, which is our salt. And then that is going to be our answer. So that was the first example problem. Hopefully that made sense. I'm just gonna erase this and then we can get another problem going. So this one we have, this one's a little bit more complicated. It's gonna be, if you can see that, yeah, Ki plus PbNO3 2 yields KNO3, and again we have our acid and our base, KNO3 plus PbI2. Hopefully you can see that. Yeah, barely. Okay. Yeah, so we have our acid and our base, and it looks like this. Yeah, it looks like this equation is pretty much already balanced. So we are going to find out how many grams are in the PbI2. So that's what we're gonna find out, PbI2. And then to start the equation, we have, so we're given the 300 grams of the PbNO3 and then we're gonna times that, to cancel it out, we're gonna times that by 1 mole over, and then this is where we need to look at our periodic table to add all of them up. So I'm just gonna do this on the side real quick. So we need to find out PbNO3 2, we need to find out the mass of it, so we need to add them all up. So this one, looking at our periodic table, is going to be 207, and then the nitrogen is going to be 28, and then, keep in mind, since there's a 2 here, that means there's going to be 2 of these and then 3 of the oxygen, so make sure your math is right in multiplying all of those. And then this is going to be 96, and that all equals 331 equals 1 mole. And then let's just go ahead and do the PbI2 as well. So we already have that mass. That one's going to be 207 plus 127, and then there's 2 of those, so that's another 127. And that one is going to equal 461. Hopefully you can see that, yeah, 461. So moving back onto the math, we have our 1 mole over our 331 that we got here. So that's going to be 331 grams of the PbNO3. So we can go ahead and cross that out. So that's done. And then we're going to move on to, yeah, this one's quite a bit of a lengthier problem. And then we're going to times it by 1 mole PbI2 over 1 mole PbNO3 times, and this is where we get our second number from, the 461. So that's going to be 461 grams PbI2 over 1 mole PbI2. Here, sorry, 1 mole PbI2. So we can go ahead and cancel those out. And then last one are over, 300 grams times 1 mole over 331 times 1 mole over 1 mole times 461 over, so that's going to be it. And then we're going to multiply all the tops and then divide all of the bottoms. And then that is going to leave us with 417.8 grams of PbI2, which is going to be our answer. And basically that is just a quick review of stoichiometry.